So stacks and queues that we did, that was a exe. It was a project that we created where we added a main, and we are calling from main all these functions. So for today we want to make stacks and queues our library so that we can use in the next projects. So what is the way to make library? One way is you start a fresh project, you create a new project, and here generally we pick console application, which means output of our project is an exe, console application. But if you are making a library, it should be a static library. If you pick that as a project, then you don't need to add a main. You add your headers, you add your code, and after you compile, what will it generate? It will generate a .a file. So if you name your project as test, it will generate libtest.a. So that is library file, binary version of your code. So that if you want to give it to someone else, you are not showing your implementation. You are just giving them binary and say use it. So because we created it as a exe, we want to modify the same project to produce a library. So what we will do as a first step, I'll open the folder. I'll right click this, go to open containing folder. Here I can delete main, that is one. Second, from here sources, I can right click and I can say remove file from project. This means I am removing it from the project, but it is not going to be deleted. But our project does not include that file now. So first thing we have done is we have just excluded our main. Second thing, we want to change this project to generate a library. So we right click and go to properties. In properties, there will be build targets. So this is build targets tab. In that there is debug and release. So in debug we are going, and here it says type. Type is console application. So here we can click and change it to static library. In release, let me see. In release also, let's change it to static library. So both we have made static library, and we say okay. Here if you see, it is showing output file path, output file name. Here also it is showing libstack and queue.a. If we want to change that name, we can change here. So next time when we compile, this is the file that will be generated. So I say okay, and now let me compile it. So compilation succeeded. I right click and say open containing folder, go to bin, go to debug, and now if you see, there is no exe, there is a .a file. So if we have to give our project to someone, how will we give? We will give three headers: linked list, node, queue, and stack. Because queue is having hash include of linked list node.h, so that should be given. Stack is also using linked list node.h. So these three headers along with lib, if we give to someone, he should be able to use our project and code. He should be able to use our stacks and queues. But before doing that, we'll have to modify it, because we want to use it with binary trees. In binary tree, we don't need a stack which stores integer. We need a stack which stores what will we store on the stack? Pointer. Our BT node. That is what we are pushing. That is what we will be popping. So where do I go and make that change? Good thing we did was we defined a type def. After that, all of them were using element type. So what we do here, we say, now where is BT node defined? In our header. So that means in order to get that, we'll have to do a hash include here also. So that also needs to be included so that we can use. It says unknown type name BT node. So one more header we have to bring from our binary tree, and that header is BT node. So that also I bring, I'll paste here so that we don't forget to copy in the headers. And second, let me put here also. So here we have just pasted. We have to include that in our project. So right click and say add files. It will show all the files that are there. One file we have added. It comes as part of this project. So the file is there, and do hash include btnode.h. But this way, tomorrow if we want to put binary search tree node, then again we'll have to include that file. Is it a good design? Is it a good thing? Every time we are adding file, we are modifying this.
Put all header files in one file and then
Yeah.
And standard library.
So in standard library, malloc returns a pointer. Does it return a BT node star? What does it return?
generate.
A generic pointer, which is void star. Right? So how about if we also make it void star? That means we can assign any pointer to that. We can read any pointer from that. That is more elegant. In that way, we will be able to use stacks and queues for anything. Tomorrow, if we want to store integers also, we'll just store the address of integer rather than integer. Very generic library we'll be able to build. So we don't need to include BT node here. This is not a good design, not a good choice. So let's remove it from the project. Let's remove it from here. Bin debug. We don't even need here. Now we are all set. It becomes void star, right? So let us quickly check in stack or queue if we have used int anywhere. Element type, NQ and DQ. Mainly these are the two functions that return. So both the places in element type, not a problem. Stack.h, both the places element type. Push, pop and peek. These are the three functions that deal with element. So fine. So compile it. Okay. This hash include also has to go away now because we are using void star. Now if we compile, our library is ready. So what should we do in order to use it? These three header files I am copying. I will go and put it in where our code blocks is installed. C program files 86. Here it will be code blocks. In code blocks there is a mingw folder. Mingw is a compiler folder that has include for hash include files. There we will put our header files. All the files that we include are stored in this folder. So we copy our file also here. It will need admin rights, so you just say yes to that. So all these files are, three files are copied in this folder. That is first step. Second, lib that we have created, we have to copy in lib folder. So bin debug, this is the lib. So that we bring here. So lib is added and our headers are also added. Now we have to somehow consume that just to see whether whatever we have done is working fine or not. So there is one more step that we have to remember. Whenever we are linking, whenever we are compiling, lib that we add, we have to specifically tell to project that you have to link with that library. We'll see how. So let me create a new project, a small way to quickly check whatever we have done is working fine. So let me say lib test. So I'm testing the library that I have created. So a new project is created, main. So here we want to create a stack. So first I'll do a hash include. .h. It should have given auto completion. I don't know why it is not working. Generally it should give auto completion for all the headers. Let me see, is it coming for others? For others also it is not coming. Maybe some problem on my computer. But now after doing these steps you should be able to see auto completion of stack.h and q.h. Let me close it and start it again because we want to cover. Where did I create? On desktop I created lib test. I'm opening the project again. Okay, now it is coming. So q.h also we can include. So let's test our stack. Stack star s equals. So now if you see, it is listing all our functions, but we don't have source code added to this project. So all of them it is picking. Create stack. After we have created stack, let's call push. In push we have to give two things. First is, second is, what is our data? What should I pass? Void pointer. That means if I am storing int 5, how should I store that?
Casting of int and 5.
Asterisk of
Cache, we need to cache now, sir.
Int star.
To void we can assign any pointer. So
Yes, sir.
casting we can ignore. Even if it gives warning, we'll do the casting.
Then
So
we'll
first I
declare-
need an integer.
Declare and this.
Declare an integer I equals 2.
Star I.
Star I? No, we are just declaring I. When we are storing, we will give the address. So now we have given the address. But once we pop, then we need star. When we pop out,
Yes, sir.
we need a pointer. So with this we have just pushed. Let's check. Is empty, and we say %s, we say is stack empty s. If it is empty, then we should say true, else we should print false. We are just printing a string based on the return type of the function. Then we will do p is equal to pop of s. Pop of s will give you void pointer, but we are taking an in pointer. And then we want to print the value that we have popped, which is an integer. So let me put a new line here, new line here. How do I print the value of I? P contains the address of I.
Start.
In order to print the value, we'll do star p. Now ideally this code should work, but for now we have not told where our library is to which it should link. Our library's name was libstack.h. So it doesn't know the stack that you are using is there in that library. So for that you have to do one step, settings, compiler. There is an option linker settings. Okay, I think that is already added for me. I'll delete it. So go to this linker settings and say add. In add you have to give path of the library with which you are linking. If you remember, we have put it in this code blocks, mingw, then lib stack and q. So we give that path and we say okay. So all the setting that we have done, it's a global setting. Next time you create a new project, the setting will be there. So settings, compiler. If you see, this is global compiler settings. So next time it knows always it has to include this library for us in any project. That's why you were saying previously it was added. So we say okay. With this, if we compile now, compilation succeeded. That means it picked our library and it linked. Now let's run it to see. First it says it's not empty because we added one value. Second, it pops that, it prints that address. So without any typecasting, we are able to store and retrieve. So this is validation of our thing is working fine. Now we can go to the second project. Any doubts on this?